Yeah, so hi everyone. I'm Nitya from the team building Capsule, and we're going to be chatting about different kind of on and off-chain approaches to trust in transactions. Just a little bit about me. I'm the founder of Capsule, and then before this, I spent some time in fintech and the L1 space, building Cello. And so maybe to get started, we'll sort of level set around what happens to form a transaction. So today, and we'll mostly be talking about the interfaces between apps and wallets, which is something that we think a lot about, and what the trust assumptions are between apps, wallets, and users today, and then different models for how I might think about it. So today, apps are more or less tasked with kind of collecting a user's intention to do something, turning that into a transaction to propose, and then wallets are typically tasked with collecting a confirmation that that transaction should be signed, and then of course they're passed along to a chain where they're executed and settled. So could more or less generalize wallets as an approval layer. So this has all changed a lot in the last year as well, and we can talk about the implications of that. But more or less what we've done up till now is that wallets have been tasked with being this neutral, almost trusted kernel responsible for accurately presenting a transaction that's about to be sent to a chain. And this is true of really any wallet, whether it's someone choosing to set up a public-private key pair on their laptop, whether it's a mobile wallet, or really anything in between. And then because of this, we've had this paradigm where apps are default untrusted. So this means that this has some benefits, namely that if I want to claim some sketchy airdrop, I can do so with knowing that my wallet is going to accurately present me some information, or rather at least that I can interpret that information and hold my own destiny, for better or for worse, around what's going to happen if I sign that transaction. But of course, it comes with some trade-offs. From the app perspective, it means that it's very difficult to build user relationships. So an example of this might be if I'm building a social app, maybe my users have to go and download a wallet before coming back, and it's difficult to build kind of the deeper product relationships and interactions that we're used to in a Web 2 paradigm. And then this interface is very explicit. So the wallet's job is to basically turn that transaction into something human readable and accurate, and then it's up to a user to interpret that and then accurately either confirm or deny a transaction. And then what's changed a lot in the last year is the app and wallet layers have really merged together. So we have a lot of applications that have started integrating embedded wallets, as well as wallets that have started integrating functionality historically left to apps, things like staking, swaps, etc. So there's a few different ways that this approval has shaken out. So the first is more explicit approval. So these are all of the dialogues that we know and love, where there's a series of information around things like nonces, what RPC is being used, etc., that a user needs to go and confirm. And then this, of course, has a benefit of it being entirely left to a user, and the user can really own whether or not they want to approve a transaction or not before it gets sent to a chain and signed, of course. The downside is that friction is really high. So this looks like maybe you're in the middle of playing a game, and before it's your turn to play the game, there's a pop-up that you need to kind of field off before you can continue. And so this really led to option B, which we're seeing more and more of. This screenshot is, of course, from Workcast, where the transacting is entirely in the background. So instead of having this two-application interface where there's the app and the wallet, they've both been merged into one, and the app is trusted to correctly kind of turn my hello HCC message into a transaction, put on the right chain. I'm not really interacting with the chain directly in that sense at all. And this is, of course, great for apps because it means that user flows can be more straightforward. But there's downsides where the user is trusting the app. This gets even more tricky in contexts where you might have one wallet that you'd like to interact with many different apps. If it's one thing if I'm trusting a single wallet, a single app with an app-specific wallet. However, if I'm now trusting 10 apps with that single wallet and any app can do anything at all, eventually my wallet will probably be drained because there's the same problem of just a proliferation of access. So what we've been, one thing we've been working on with Capsule is an option C. So what this looks like is, given a world where apps are condensing these interfaces, rightfully so, because apps want to build deeper relationships with end users, how do you keep that trust explicit? And how do you prevent these kind of infinite like wallet draining type attacks? And so what's a little different about this is, instead of wallets being this kind of default kernel, they're instead a permission management layer. I can go into what that looks like. And then the first app that someone uses, similarly, is default trusted. There's an empty wallet, so an app's trusted to operate on it. But incremental apps that a user connects to are default untrusted. I think what's a little bit different about this model versus the pop-up world that I showed before is that we like to give apps a way to gain that trust over time while keeping that interface explicit. And what this looks like is, instead of approval at the time of transaction, pre-approval for certain types of transactions. And these are limited to a session. And so this is not kind of unique to us at all. I think this notion of programmable transacting has been popular and explored for quite some time. I think the most popular version of this today is, of course, account abstraction and session keys, where people think a lot about how can you provision a session key that gives a certain application access to perform some set of actions on a wallet that is scoped within a smart contract. And so there's some benefits to this approach. Of course, you can program approval logic within a smart contract. There's some downsides to this approach as well, namely that this has to sit on a smart contract on a chain, and therefore you end up with like large proliferations of operations needed when an application maybe spans 10 different chains. So as a complement to this, we've been exploring an off-chain complement. A very quick kind of primer on Capsule to contextualize this. So we're a 2 of 2 non-custodial MPC wallet. And that's a lot of words to basically say we make it easy to provision wallets when users are onboarding to new applications, but then also allow those wallets to be interoperable across many different applications. And so back to that first problem I mentioned, we're really focused on solving this problem of how do you have a wallet exist in the context of many different apps without allowing every app to do anything they want to on the wallet. And so the way we've approached this is by using MPC resharing as a way to have scoped share level access to different applications. So what this might look like, and on the right are just some screenshots from the product, but giving users the option to either create a new wallet when they use a new untrusted app or to connect an existing wallet. And then we've introduced this. It's actually fairly new. We'll be announcing this in the next couple of days, but something called auto transaction mode, where you can start out with a fully untrusted paradigm. Let's say it's a brand new app. You just want to do one transaction. You don't have to trust that app to do anything in the background. But then over time, you can provision really granular contract or even contract function, parameter-bounded access to different types of actions. So this could look like something like, let's say, opening a limit order and allowing an app to open a limit order on your behalf, allowing an app to execute a swap on your behalf. Things like this, and because of the key share level access, you can also revoke these permissions fairly easily without either requiring users to have many different wallets or requiring things like infinite, like unscoped access to wallets. So just going to share an example of what this looks like in action. So see a couple of
You might need to be in the slideshow notes too.
Oh, right.
Oh, are you connected to Wi-Fi?
Oh, I'm not connected to Wi-Fi. That's all right. Yeah, so basically what we're going to show here, I might actually just have this on my laptop. Let me see if I can open that up.
There's also the Wi-Fi password just behind you on the board.
Oh, great. Okay, maybe I'll do that then.
So at summer 24.
And it's someone's request. Sorry about this. All right, success. Thanks everyone for the patience. So what you'll see here is there's an app that we're going to call red.com. I've newly onboarded to red.com, and therefore red.com can do anything they want with this freshly created wallet. So we're going to nicely sign a message. But now what happens if I want to use blue.com? So I'm going to connect that same account, but then when I sign in, I'll be prompted to select the wallet that I'd like to use. So here I can either create a new one or choose one of my existing ones. And then we see this auto transaction mode. So can offer maybe granular access around either maybe just minting NFTs in the background or just transferring ETH in the background. And then that gives this app, for the course of this session, selective privileges. And so what we'll see here is the minting happens in the background. Anything that is outside of the scope of permissions, which are governed as a set of contracts and allowed functions, would require a third-party approval. So that's how we think about the initial case of a user coming in, can have a fully untrusted app, but then over time build up more and more trust. So maybe the next time that I use this application, I would want to trust it to transfer ETH on my behalf. And so it's more progressive on the case. Yeah, so in terms of what's next, so there's a pretty, I'll talk a little bit about the trust assumptions involved here. So the permission system itself is default. It's an initially closed system, and a lot of the reasons for that are to just allow a kind of fast go-to-market iteration, but looking at opening up this system, following things like on-chain permission standards, making this kind of an open interface that people can program against, publishing the schema, and then from there looking at further even decentralizing the MPC operations and who can have a role in this operator network. So a couple of kind of future plans there. But yeah, that's all. Thanks everyone for coming.